Hello, everyone. Thank you for joining me today. Another page of notes with Mr. Jankowski. We're going to try to get page 323 and 324 from your GOMath textbook done on this one video. So you can see here, this is page 323, and then we also have page 324 on the next slide. So we're going to try to do both of these pages in this one video, and let's get started. I'm going to zoom in on the top of page 323. We have a problem that's from page 322, but we can do this one really quickly for review. It says at the top here that we need to graph the solutions of the inequality t is less than or equal to -4. So if you remember from last video or from last week, I'm going to graph this on the number line. I'm going to find -4. And because t is less than or equal to -4, I'm going to be using a solid graphed point there for -4. Now, which way do I need to go? Well, t is less than or equal to -4, so everything to the left is less than -4, which is a solution for t, including -4 itself. So let's move down. We're going to be talking about the next section here, writing inequalities. And it says here, you can write an inequality to model the relationship between algebraic expression and a number, or to represent a real world situation. I'm not reading this perfectly correctly, but I'm going to keep going. It says the variable in an inequality can represent an infinite number of numbers. And that's kind of hard for people to understand. Like up above here, we have t is less than or equal to -4. Well, -4 is the solution, and everything to the left of -4 going on forever. And that means all the numbers that are in between these negative numbers as well. So like fractions and decimals in between from -4 all the way left on the number line going on for infinity. So it's kind of hard to understand. We don't actually list all those numbers on the number line, obviously, because that would take up too much space. But this arrow that we have here says that this line is just going to keep going forever. So everything to the left of -4, including -4, is a solution for t. Okay, so let's take a look at part A. We have our second example. It says, write an inequality that represents the phrase, the sum of y and 2 is greater than 5. Draw a graph to represent the inequality. So we have the sum of y and 2. We know that sum is addition, and y plus 2 is what this is. So the sum of y and 2, y plus 2, is greater than, so we have the greater than symbol, 5, and then there's 5. So if you were to write this out as a full inequality, you would write it out like this: y plus 2 is greater than 5. Okay? Now, what they say in the book is to graph the solution, and you can use mental math for this. It says for y plus 2 to have a greater value, or that have a value greater than 5, y must be a number greater than 3. So if you plug in any number that's greater than 3 for y, so let's try 4 plus 2. I'm going to use a different color here. Plus 2 is greater than 5. Well, of course, because 4 plus 2 is 6. 6 is greater than 5, right? And I could try out any number here to the right of 3. But it cannot include 3 as a solution because we have this greater than symbol. We don't have greater than or equal to symbol. So another way to do this is, we could solve the inequality. So we've done this a lot last week. If I have y plus 2 is greater than 5, well, I can solve this as well by getting this y by itself, isolating the y. Use inverse operations and subtract 2 from both sides of the inequality. These 2's get eliminated, and I'm left with y is greater than 5 minus 2, which of course is 3. So you can use mental math. You can also use an algebraic method to solve for the inequality. But they've graphed it here. We have a circle, open circle over the 3, and the graph going to the right because y is greater than 3, but it's not equal to 3. That's why we have the open circle. And then they have step 3 to check your solution. And we can try this out using the original, and I already did this actually up above, but using the original inequality, which is y plus 2 is greater than 5. So they did that here. They plugged in the 4, just like we did up above. They plugged in the 4 for y. They said 4 plus 2 is greater than 5. Of course it is, because 4 plus 2 is 6. 6 is greater than 5. Okay, so we have our second example. And this time we have a real world situation, a situation that you might run into in everyday life, right? Um, so let's read this real world situation and see what it says. It says, to test the temperature rating of a coat, a scientist keeps the temperature below 5 degrees Celsius. Write and graph an inequality to represent the situation. So the situation is he needs to keep the temperature below 5 degrees Celsius, right? He doesn't need to keep it exactly at 5 degrees. The scientist needs to keep it below 5 degrees Celsius. So we're not going to have a less than or equal to. We're just going to have a less than. And they have this here. Let T represent the temperature of the lab, but we have T is the temperature of the lab is less than 5. So the temperature of the lab needs to be kept less than 5 degrees so that they can test the temperature rating of this coat, right? So we have T is less than 5, and then they graphed this down below. They circled a point on the number line for 5, and they said T is everything to the left of that. Now we can test this just like they've showed us before. So if we have T is less than 5, and they're saying that this graph is a solution, everything going to the left is a solution from 5, because T is less than that. I'm going to pick a number that's part of the solution and see if this works. Let's try 2. So I'm going to take 2 and I'm going to plug it in for T. So I'm going to have 2 is less than 5. Well, is that a true statement? 2 is less than 5. Yeah, I think we're good. We checked it. Now you could check these as well, the other numbers too. Obviously, this line goes on forever, so you wouldn't be able to check all of the numbers. But just checking one or two of those numbers that is on the number line shaded, just to double check is a good idea to see if your solution is correct or if your graph is correct for the inequality. Okay, so I'm going to show the full page here. Remember, this is a video. You can pause, you can rewind it, you can watch it again. But I'm going to go on to the next page, our last page for this video, 324. And we're going to take a look at this next. Okay, so I'm going to zoom up to the top, page 324 in your math textbook, GOMath textbook. And we have our first problem to look at here. Number 4. Write an inequality that represents the phrase, the sum of 1 and y is greater than or equal to 3. Check to see if y equals 1 is a solution. Okay, let's look up some clue words here in our phrase. The sum of 1 and y. So we have the clue word sum. And then we also have greater than or equal to 3. Now, looking at numbers here, we've got 1, we've got y, and we've got 3. Okay, so if I was to write this equation, I'd probably write it like this. The sum of y, or 1 and y, so it'd be y plus 1. Now, I could also say 1 plus y. The commutative property of addition says I can add in any order I want. So I could do that. I could put 1 and y instead. Maybe I'll do that instead. So just like the sentence says, 1 plus y. And then it says is greater than or equal to 3. So I'm going to put greater than or equal to 3. Okay? Now, we wrote the inequality here, and they want us to see if y equals 1 is a solution to this inequality. So what I'm going to do is I'm going to take this 1 and I'm going to plug it into y. Plug it into y and see what it works out to. So I'm going to rewrite this equation as 1 plus, instead of y, it's going to be 1, just to see if this works, is greater than or equal to 3. Now, if I add this up, this is 1 plus 1, and that's 2, is greater than or equal to 3. That doesn't make any sense. That doesn't work, right? 2 is not greater than or equal to 3. So this is not a solution. 1 is not a solution to this inequality. Now, what would be a solution? Well, we could do 2, right? 1 plus 2 is 3, and 3 is greater than or equal to 3. You could do 3, so 1 plus 3 is 4, so 4 is greater than or equal to 3, and then everything that is greater than that would work, would be a solution. Let's look at number 5, our next one. Here's another real world situation. We have the temperature in February was at most 6 degrees Fahrenheit. Write and graph an inequality to represent the situation. Tell what the variable represents. Okay, so let's start looking up some clue words here. And actually, I'm going to circle the numbers first. We have 6 degrees Fahrenheit. There's one. Okay. And that's all we have so far. Let's look up clue words. Temperature in February was at most. At most. That is definitely a clue word, at most. Now, if you look at our clue words and phrases for inequality, you'll notice that at most means less than or equal to. So what I could write here is this. I could put temperature for my inequality. Temperature is at most, which would be less than or equal to 6 degrees Fahrenheit. Now, what does the temperature represent? Well, the temperature represent, or T represents, the temperature in Fahrenheit. And then to graph this on the number line, I have a less than or equal to, T is less than or equal to 6. I'm going to find 6 on the number line. There it is. Since this is less than or equal to, I'm going to make this a solid dot on the 6. And then I'm going to shade to the left. Everything to the left is a solution, including 6. All right, let's move down to guided practice. Our first problem for the guided practice, number 1, says graph 1 is less than or equal to x. Use the graph to determine which of these numbers are solutions of the inequality. Is negative 1, 3, 0, and 1 solutions to the inequality? Let's see. So I'm going to graph this first. 1 is less than or equal to x. And I talked about this with my other classes. You know, if it confuses you, you can always rewrite this in a mirrored way. You can write this as x is greater than or equal to 1. It's the same thing. It's just written differently, just written mirrored. So I like to see it like this, and this is the way I'm going to graph it. I'm going to graph it in red, and I'm going to find 1 on the number line, which is right there. Since x is also equal to 1, but also greater and equal to 1, I'm going to give it a solid circle, solid dot on the number line, and I'm going to draw an arrow to the right, indicating that all these numbers, including 1 to the right, are solutions to this inequality. So what numbers do we have in our list here that are actually solutions? Well, negative 1 and 0 are not solutions, but we've got 1 is a solution, and so is 3. So I could write here that the solutions are, at least in our list, solutions, we have 1 and 3. Obviously, 2 is a solution, 4 is a solution, 5 is a solution, and everything to the right on this number line is a solution. But given the numbers that they have here, yes, 1 and 3 are solutions out of this list. So the next one, number 2, it says graph negative 3 is greater than z. Check the graph using substitution. So I'm going to rewrite this again. This is just me. Maybe others can see this better and they don't need to do this, but I like to write the variable on the left side. So I'm going to rewrite this as z is less than negative 3. And then I'm going to graph it on the number line. So I'm going to find negative 3 on the number line. There it is. Z does not also equal negative 3. It's just less than it. So I'm going to give it an open circle on the 3, negative 3 rather, and draw to the left. Now it says the second part, check the graph using substitution. Okay, so I can check the graph using substitution by looking at what's been shaded. Well, I've got a -5 here. That's part of the shaded area at the number line. So I'm going to try that. I'm going to substitute -5 in for z and see if this works. So I'm going to put -5 instead of z, and I'm going to put is less than -3. Is this a solution? Yeah, -5 is less than -3. So this is good to go. We checked it. All right, next, number 3. And remember, you can always pause the video, restart it, rewind, whatever you need to do. So if I'm going too fast, please don't let any of that stop you. Pause the video and get caught up. Here we go for number 3. Write an inequality that represents the phrase, the product of 3 and x is greater than 6. Draw a graph that represents the inequality and check your solution. Okay, so let's look at the numbers first. We've got 3, we've got x, and we've got 6. And then clue words. Well, we know we need to make an inequality, right? That represents the phrase, the product of, so this is always multiplication when you're talking about the product of, is greater than 6. So to write this, I know I'm going to be using multiplication. The product of 3 and x, well, that's 3 times x, or just 3x. And then I could say is greater than 6. I'm going to have a greater than symbol, and then 6. Now, how do I graph this? Well, this is what I like to do. I like to solve my inequality problems here. Get the variable by itself. Makes it a lot easier for me to graph, to isolate the variable. We've got 3 times x. The inverse operation of multiplication is division. So to get this variable by itself, I'm going to divide both sides by 3. Now, 3 over 3 is the same as 1, and 1 times x is just x. So I can write this as x, saying these 3's are eliminated, but I still need to do 6 divided by 3, which of course is 2. So I'm going to find 2 on the number line. This is greater than, x is greater than 2, so I'm going to make it an open circle, and I'm going to graph to the right. Now I need to check my solution. I've already got this simplified, right? X is greater than 2. So I'm going to use that. And I'm going to plug in one of these numbers. I'm going to substitute one of these numbers. Let's try 4 into x and see if this checks out and works. So let's see. Instead of x, it's going to be 4 is greater than 2. Obviously, 4 is greater than 2, so we're good to go. We graphed it correctly. Okay, next, number 4. Let's start this. During hibernation, a garter snake's body temperature never goes below 3 degrees Celsius. Write and graph an inequality that represents this situation. Tell what the variable represents. Okay, so snakes, it never goes below 3 degrees Celsius. I'm going to look up some of the numbers I see here. We see 3 degrees Celsius, right? And then clue words, never goes below. Okay, so if it never goes below 3 degrees Celsius, that means it never gets to 3 degrees Celsius, right? It never goes below 3 degrees Celsius. It never gets to 3 degrees Celsius either. So we can write T is greater than or equal to 3. Snakes, of course, are cold-blooded, right? So if they went below a certain temperature, they probably wouldn't survive. So the temperature for these snakes needs to stay greater than or equal to 3 degrees. Okay? So let's graph this on the number line. I'm going to graph this in red. I'm going to find 3 degrees, or 3 on the number line. This is T is greater than or equal to, so it's going to be a solid circle, and I'm going to graph it to the right. Now, what does T represent? Well, T represents the temperature in Celsius. So I'm going to write T is the temperature in Celsius. Let's fix that in. All right, we have one final problem here, number 5. And I'm going to read this out loud for you. Write an inequality to represent this situation. Nita wants to take at least $15 to the movies. How did you decide this inequality? How did you decide which inequality symbol to use? Okay, so if Nina wants to take at least $15 to the movie, that means she could also take exactly $15 to the movie, right? She can take at least $15 to the movie. She could take $15, but she doesn't want to take any less than that. So what we're going to put here is D for dollars that she's going to take to the movie is going to be greater than or equal to 15. She doesn't want to take any less than 15, but 15 would be okay. So what we could write here is this. D represents, and actually I'm going to use lowercase d because that's what I have for my variable, but D represents, let me use a semicolon here. D represents dollars, the amount of dollars. Nope, one M on that one. Rewrite that whole word. Of dollars. And at least means that Nina wants to take $15 or more to the movie theater. Quite frankly, I agree with Nina. Can't buy much at the movie theater for less than $15 these days. So there we go. We have all 2 pages that we did in this video completed. I'm going to zoom out so you can see the whole thing. Remember, this is something you can stop, rewind, watch again if you need to. We have 2 videos for these 3 pages of notes. The other video is also in the list on the playlist to watch for page 322 if you haven't watched that yet. So thank you for watching these videos. Thank you for taking notes. They'll come in handy. You can use them on the quizzes and on the tests. Have a great day today, everybody. I'll see you in the next one.